Hi, this is David Tudor. Welcome back to my series on mathematical modeling of the coronavirus outbreak. This has been some time since the last video I made. The last one was on asymptomatic cases, and we're going to come back to that in the next video because it's too important to leave behind. But in the meantime, I want to do this quick video today about, do we see the light at the end of the tunnel? Can we decide that the curve is leveling out or dropping? And how do we in fact decide if it is or not? In the video today, I'm going to use the binomial law of probability. We're not going to get into formulas and things like that, but the binomial law is the one that you use to decide probabilities of outcomes when you're tossing coins for a length of time. So the way we're going to use it in the coronavirus modeling is to decide whether we think that the curve is increasing or decreasing or accelerating or decelerating. So in order to use the binomial law, we're going to go back to the normal law. The normal law is our old tried and true favorite bell-shaped curve. And there we can decide, thinking of zero as being no change at all, the curve is neither decreasing nor increasing, or the curve is neither accelerating nor decelerating. So we're going to use that, presume that there would be a fluctuation of our curve around some kind of steady level, and decide whether the observations from day to day are increasing or decreasing or positive or negative. So to do that, the first thing I think we need to do is to have just a quick look about what a slope is. Slope is also a speed or velocity. And in looking at slopes, we look at the rise. That is, we have a graph here, and we have some, on the right-hand side here, a change in our y-coordinates, vertical coordinates going up and down, per change in our x-coordinates. So our x-coordinates in all of these graphs are going to be measure in time, measure from day to day of new hospitalizations or new cases. So our unit is usually going to be 1 day. That makes the calculations very easy. We don't have to know anything about triangles or trigonometry, anything like that. So we just need to know whether we have an increase or a decrease in for example, the new cases per day. So this is typical curve that we would get going up the left-hand side of our epidemiological curve. So at that point, the instantaneous rate of change will be seen as just the hypotenuse of the little triangle that we looked at a minute ago. And this is a tangent line, and we look to see the slope of the tangent line. So the slope would be that rise over run that we were talking about. So high slope means that we're going up a steep curve, and low means we're settling down and arriving at the peak of the curve. So each time that we go from one day to the next, we'll look at the slope of the curve, and we see that for this first part of the curve, not only can we say that the slopes are positive, so it's going up and going up and going up, but in fact, throughout this interval that we're looking at right now, the slope goes up and then it goes up again. Now, this special point here is the inflection point. It's the point where there is no real tangent line. It goes through the curve and gets us over onto the part of the curve where we're nearing the peak. So notice that at these points, when we look at the tangent lines here, we have points that are still, the slope is positive, which means the curve is increasing, so that our slopes are positive, but in fact, the slopes are going down, so our slopes are decreasing. So here we need to keep straight whether we're talking about the curve increasing or decreasing, or the slopes increasing or decreasing. And so the slopes here, when we look, we'll say that this is accelerating because the slopes are getting steeper, and then through the rest of the curve, it's decelerating. So we decelerate just before we get to the peak and go down. In order to use some data, as you noticed in our last video, I used data from France. In this video, since I wanted to get more of an idea of the curve going up and accelerating or going up and decelerating, I wanted a curve that was a bit more complete. So I went to Italy, who has had many more cases than France and most of the rest of the world except for the U.S. And in Italy, it looks like the curve is slowing down. So we will be able to see whether we actually believe that or not. So I'm just showing you this, the Worldometer's website in order to get my data. So they have a very nice curve here, lots of different things about active cases, cumulative cases, new deaths, new cases. So I went up through here, and day by day I copied down the totals that you see along the curve here, and I put that into an Excel sheet. So my Excel sheet here, notice that I've taken the active cases in Italy, so I've written the date down and the day, 1, 2, 3, so I have just numbered the days. My number of active cases, number of active cases, I copied this particular column out of the website that we're looking at in the background there. Now, to see whether the numbers of cases are increasing or decreasing, I've taken, as you know in Excel, I've taken this cell, C4, minus this cell, C3, in order to get the cell 1. And the 15 here comes from 19 minus 4. So I've done that to calculate the number of new cases every day. And notice the curve is going up, so all of these new numbers of new cases are going to be positive. And we'll see whether those numbers of new cases are changing. So we do that by going back here and doing the same thing we did before to calculate the acceleration. I take the 15 minus 1, but since I've done that over a period of 2 days, I have to divide that by 2. So I have 14 divided by 2 is 7. So I've done that for all of these cases to see whether my number of new cases are going up and down. And that's what I'm going to use to decide whether we're seeing the light at the end of the tunnel, whether we are approaching that peak or not. So can we be optimistic or not? Now, you'll see here that I've reproduced this graph, not as pretty as the one in the website, but I see the number of days going along here up to 47 days, and my curve is going up. The number of new cases is always going up, so my derivative, my slope there, the slope is always positive. But what I really want to do is to know, is that slope increasing or decreasing? So this is where I use the binomial law to say, is that increasing or decreasing? I wanted to use the binomial law to try to decide this, because here you can see this is a plot of the new cases, so our slopes. And notice that they're all positive. This whole graph lies on top of, above the horizontal axis, but it's hard for me to tell. It looks like it's going up and then going down, so it looks like we may have gone through that point of inflection where we're changed from accelerating to decelerating. And I think we probably are, but statistically, can we really conclude that we are? So in order to try to do that, I've plotted here my acceleration curve. Here I've simply have connected the dots of this column of the changes in the slope. So is the slope going up or going down? So here I can see that my acceleration is decided around 0. So and my acceleration is positive if this curve lies above the horizontal axis, and my acceleration is negative, that is, I have deceleration for lying below the horizontal axis. Now what we want to do is look to see, for me now, simply looking at the number of dots above the horizontal axis and the number of dots below the horizontal axis, I can see that it's not quite so clear. It looks like lately there may have been more negatives, and if we look in the actual data here, it does look like maybe we've had more negatives. Let's count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 9 out of 16. Is 9 out of 16 a lot? It's more than half, but is that enough evidence to believe that it's true or not? So we have an Excel, if I look at the number of observations in a row, so I go here from the 30th of March down to the 14th of April, that was yesterday, I have a series of observations. So I have 10 in a row or 16 in a row, and I have a number of negatives, a number of decelerations that I've observed in there. So we just looked at 16 in a row, and we said that there were going to be 9 decelerations. So how probable is it for me to observe 9 negatives in a row of 16? It's 0.175. That's my probability of observing 9 out of 16. So you can play with this. You'll get this Excel sheet and the link right after this video. But here you can say, out of a row of 6 in a row, how many? What if I get 0? That's highly unlikely that I would have all negatives 6 in a row. That would be an unexpected result. Usually unexpected in statistics is less than 5%. So this is 1.6%. So that would be unexpected. If I get 6 negatives in a row, I would say, yes, it looks like we're decelerating. However, if I looked at 6 in a row and only saw 1, regardless of where it is in the row, that's only a 9% probability, and so I wouldn't think of that as being a very rare event. So anytime you get up to 6 or 7, I can see that even 1 out of 7 is not very rare. 0 out of 7, if I had 7 in a row of negatives, that would be 0 in a row of negatives would be increasing. So I would conclude that it's not really decelerating, but in fact it's accelerating. However, if I saw 7 out of 7 negatives, that would be the same probability. These probabilities are symmetric in the binomial law. So if I have 6 out of 7 negatives, then that would not quite be enough to be a rare event. If I go to 8 in a row, if I look at 8 days in a row, and I notice that I have 6 out of the 8 are negative, that's not really enough. 7 out of 8 is in fact 3%. So 7 out of 8 would, if I looked at a string of 8 days, and I noticed that 7 out of those 8 were decelerations or had this negative in my acceleration column, then I would conclude that that was in fact a rare event, and that important enough for me to think that I'm not really fluctuating around 0, but in fact I have a negative acceleration. So you'll know that if I look at a row of 9 and I have 8 out of 9 or 9 out of 9, then that's going to be proof that we have a deceleration. So in fact, going back and looking at this curve leveling off, it has to be leveling off at least, let's see, what happens if we have 5 out of 5. 5 out of 5 is, if I have 5 out of 5, 6 out of 6, 7 out of 7, then I would have something. But if I have 4 out of 4, if I see a string of 4, then in fact that's only a 6% probability. So a string of 4 is not really unusual, whereas a string of 5 negatives would tell me that my curve is probably mostly negative, that I'm most likely decelerating. So we have to have either a complete string of 5, let's say 5 out of 5. That gives me something that I would think if I had 5 negatives in a row, then it's really is more negative than positive, or 6 out of 6 or 7 out of 7. When we get up to 7, we can have 6 out of 7 or 7 out of 8 or something like that. But we have to observe quite a few more decelerations in a row in order to conclude that this curve is actually leveling out. Does that mean that we can let up on our efforts to flatten the curve. You have to keep up your efforts, and we'll go back to our modeling in the next video and see about can we stop our confinement or not. See you in the next video. Bye.